Hello, welcome to my Flight Dynamic Lab video. My name is Yibo Zhang. Part 1 is the weight and balance of our aircraft. This ball is CG position of our aircraft. The blue bar is aerodynamic charge. This axis is the axis of CG. When I move this ball, we can see they are also changing in here. And I have run this model. When one can see there is three weighting scales on here. If I change the location, they are also changing in here. So let's recall this data to Excel. Now during this data, we can calculate CG position in here. This is estimated CG position. Let's compare with actual CG position with one graph. Like x-axis is actual CG position, y-axis is estimated CG position. In theory, x must equal y, but however, we can see there is a little bit different, but it's okay. Part 2 is thruster test. We can see there is a load scale in front of the aircraft and the RPM showing in top right corner. Let's recall the forces are different RPM. First, when RPM is 100%, the forces is 29 Newton, and we recall this data to Excel. The Excel shows several different forces at different RPM. Let's have a plot. X-axis is RPM, Y-axis is forces. Okay, part 3 is static control response. For this part, pressing the key corresponds to the response of aircraft. First one is elevator, aileron, rudder, flap up, flap down, throttle. Part 4 is dynamic control response. As this part, I use the CG precision is 35% MAC. There is 3-speed simulation I was used. Yeah, as you can see, the faster speed, uh, have the faster response time. There are short time to response. Yeah. For the thrust line, we need to find the relationship about CG vertical location and the angle of attack changes. We can see the unity. Now is internal angle of attack. When I fully throttle, we can get the final angle of attack. It's like this one to put in fully thruster. Now we can find the CG vertical location for zero comping is minus 0.025. Part 5 is aircraft virtual wind tunnel test. In this test, we run this model at different flap deflection, elevator deflection, CG position, and different alpha angle. And then we take this data to Excel. The first photo is CL versus alpha for 3 flap deflections. At 0 flap, the CL max is 0.9522, 20 flap is 1.035, 40 flap is 1.1167. The all CL max occur at 16.67 degrees. Okay, second photo is CL versus CD for 3 flap deflection. CM versus CL for 3 elevator angles, and then is CM versus CL plus for CG position. The last one is CL over CD across CL for 3 flap deflections. And the maximum CL over CD for flat 0 is 30.57 blah blah. CL is 0.952. Okay, the in Pandex A max CL over CD is 30. It's much smaller than the appendix. Yeah, it's like stable flying. No. Yeah, let's change the direction. Yeah, I don't know why what's the view. It now looks no good. But you can see the elevator is zero, nearly zero. It's like stable flying. I just can't see the 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 aircraft.